Good afternoon. My name, again, is John Pelosa. I'm a product manager with HVAC Solutions. We're a division of Temp Equipment Corporation, and so we have a wide range of product besides carrier equipment that we can bring to the table. One of those most closely related to today's subject is pool pack dehumidification equipment. So if you have any questions about a variety of equipment that we have, go to HVACSolutions.com. Click on our line card and you'll see the products that we offer, and also product managers like myself and who you would call for more information, or contact your territory manager. They're glad to help you with that. Okay, we always start out conversations about pool dehumidification and pool natatorium with a short discussion of pool water chemistry. For a couple of reasons. One, just to get a grounding in that subject, and two, to draw some lines of responsibility. Engineers, contractors, you're not going to be doing the pool water chemistry. The owner or the pool manager is. So, but we just want you to be somewhat familiar with the terms, so you can have a very good idea of what's going on in discussions with maybe some other equipment providers that might be working on the pool design with you, such as filtration or water chlorification equipment. So when we first fill a pool, we bring the free chlorine level up to about between 1 and 1.5 parts per million. And if you don't do anything in the pool, it will that level of free chlorine will stay right there. It doesn't evaporate. It's not going to go away. And it'll just stay there if you don't do anything. You're not going to smell it. Free chlorine doesn't evaporate into the air. It's not volatile, and it will not create any smells or odors in the pool natatorium. And finally, if you don't smell chlorine in the pool, that's a sign of good chlorine chemistry, of good water chemistry. And it's going to stay. It can stay at that level. It'll be a fairly stable situation as far as pool odors and that sort of thing. Now, what happens is when swimmers finally get into the pool, they're going to bring with them bodily fluids, sweat, urine, etc. Use your imagination, and that's when things start going south. What happens is the free chlorines are going to combine with that organic matter and create what's called chloramines or combined chlorines. That is what you smell when pool water chemistry goes bad. So again, we start out and we have a new pool or a freshly filled pool, and we just run the chlorination system, so we get about 1 to 1.5 parts per million of chlorine, or free chlorine in the pool. At this point, free chlorine will equal total chlorine. Now, when we start introducing organic matter, that's when you start getting those combined chlorines, and that is what you smell. And as long as we're below 0.2 parts per million, life is good. Things are okay. Now, once we get over 0.2 parts per million, that's when problems start occurring. You start smelling the chlorine smell, and that is a bad sign. So what do we do about that? Again, once we start smelling things, we test the water, and we exceed that 0.2 parts per million. That means that we have a chloride-rich environment, and that can condense along with the water onto surfaces in the pool and can affect the swimmers as well. So again, if we don't have our humidity under control, if we don't have our pool water under control, that water, and it will carry chloramines with it, can condense on surfaces, affecting metallic surfaces, other surfaces in the pool, paints, brick, concrete, and so on. And here's what happened. We can have accelerated corrosion of metallic surfaces in the pool. That would include even stainless steel in some cases. And of course, the swimmers are going to suffer too. So the young, the old, those with weak respiratory systems, sensitive eyes, they're all going to feel the effects of chloramines. So what do we do? Well, the most common treatment is to shock the pool. So what does that mean? What we do is we increase the level of free chlorines to 10 times the combined chlorine level. And that's essentially we're adding chlorine to the pool. And it's a pretty complex chemical process.
That's pretty straightforward to me, John.
Yeah. Okay. And, so the message here is it's a complex process. Don't leave it up to some, untrained personnel to do this. You want to have a trained pool manager. Owner should have a good idea of what's required here. And it's going to protect the pool. It's going to protect the swimmers. It will protect the natatorium. And it will protect the pool owners as well. So why do we go through this? Bad water chemistry affects everything. The metals in the pool, brick, paint, any substance in the area that can be affected by chloramines, including the swimmers.
Can I pause you for 1 second, John? Can everybody see the screen right now where it says, why do we go through this review of pool chemistry? I got someone typing and they don't see the screen. I want to make sure it's not a broad issue and everybody else can see the screen okay. Okay, everybody does see the blue screen where it says, why did we go through this? Okay. All right, Anthony, in regards to you, you may want to log out and log back in if you can't see it. Maybe there's something going on with your computer. Thank you, guys. Sorry, John.
Sorry, Anthony. Okay, and, again, we're drawing the lines of responsibility here. Owners may think that the pool dehumidification equipment or system should scrub out chloramines. That's just not the case. The pool water is emitting these chloramines, and the only way to get it out of the air is to get it out of the water. Pool dehumidification is not going to put chemicals into the air or take them out. Okay, and you just have to again know that the chloramines are in the water, and they get into the air from the water. And so, if you want to eliminate chloramines from the air, then you have to eliminate them from the water. So you need to fix that water chemistry if that's a problem. And honestly, engineers, contractors, you'll be long gone. This is something that they have to deal with going forward, so they should get proper training. That you might want to make that part of your scope of work. They can manage it themselves, or there are services. Ecolab, for instance, maintains pool water at several hotels I've seen. So here's our first question.
All right, so I'm going to launch the question. The question is, to what level are chloramines acceptable in pool water? And you have three choices. A, 0.02 parts per million. B, 0.2 parts per million. C, 2.0 parts per million. All right, you should be able to click on the choices now. All right, 82% of you guys voted. I'll give it another 10 seconds, and then I will close the poll. 5, 4, and I'm closing the poll. All right, we'll put the answers up on the screen for you there. Oops, sorry.
Oops.
All right, so the correct answer is B, 0.02 parts per million, and 75% of you guys got that correct. So nice work there.
All right, let's continue on. All right, we talked about chlorination systems. There are a couple of other technologies that you might run into when you're designing pools and pool enclosures. One is the saltwater pool, and essentially what we have here is a saltwater solution is introduced to the pool filtration system, and it passes through this electrolytic cell. and it changes that salt, which is sodium chloride, and it separates those atoms, and you get chlorine out, and that is called hydrochloric acid, and that's what you get when chlorine dissolves in water, hydrochloric acid. This is what disinfects the pool of water. I know of one. My son goes to Bradley University, and they have a saltwater pool there. Doesn't taste like salt. It's just that they use salt in the pool sanitation process. Ultraviolet. We see some of these in the Chicago area too. These automatically control chloramines to less than 0.1 ppm, which of course is well below what we're trying to control to. I wouldn't use this term in front of owners, but if you get reports of this that they claim that they're almost maintenance free, we just don't want people getting a sense of false security. You have to maintain pools, you have to test on a regular basis. They cost more, about twice as much as your regular standard chlorinators, but your operating costs are going to be less. And then you do require some free chlorine in the pool, and shocking is minimized. Now, that first cost that I mentioned a moment ago, yes, you'll pay more up front, but you're going to save a lot of money in operating costs and chemicals. For instance, when you shock the pool, some pool owners do a purge cycle. That means you're bringing in a lot of fresh air, exhausting the air from the pool and Natatorium, and you may have to reheat that outdoor air coming in. That's going to cost a lot of money in the middle of January. Here's what they look like. It's a nice polished stainless steel vessel with a UV tube in it. And so you see the UV tube in this cutaway view. There's a light sensor there in the middle, which senses how much light is coming off the UV tube. That little trolley on that screw drive, that's a cleaner that goes back and forth on the tube, clean the deposits and whatever else off the tube, make sure that the light gets the correct amount of UV, the correct intensity and duration. And it also alerts the pool owner if the light is degraded due to age or failure. So it does give off warnings and alerts if something goes wrong. Ozone Systems. I haven't seen these out there, so we'll just spend a moment on this. Again, they cost more, comparable to a UV system, take a little more room, and you do have that ozone generator on site. You're probably going to face questions about ozone, as with any piece of equipment that generates ozone. They're safe, but just be prepared to answer those questions about it. Okay, this is where we get to the good and bad parts of what we see in some pool natatoriums. As I mentioned, if you don't control your humidity in your pool natatorium, if you don't control chloramines, eventually those compounds are going to work under the paint surface, get between the concrete or the drywall, and will start peeling. The paint will separate from the substrate, and that opens up the concrete, in this case concrete blocks, to absorption of more water, chloramines, and so on. You have to control both chloramines and humidity. Again, look where this all starts. It's at the edges where the paint might be thinner, or people may put ladders up against a structural member, knock some of the paint off. And again, humidity and chloramines are going to get under that paint wherever it finds a little nook or cranny to get under and start separating the paint from the concrete, opening that concrete up to more absorption of humidity and other substances. Steel, not impervious to this either. And again, you can see at the corners, just like in our cars in Chicago, you see rust forming at areas where the paint is damaged on the edges and dents, on the edges of paint. And this is an obvious example of the chloramines and humidity getting underneath the paint, separating the paint, rusting the metal, and then condensation enough to the point where it's actually carrying the rust down this support right here. Suspended ceilings, they're bad enough, but in this case, this was used as a return plenum. So you have the air returning, again, carrying humidity. A return plenum is going to carry a higher humidity, right from the pool natatorium. It will get in between the insulation on this on the steel support here, the steel I-beam, and it will separate the insulation from the steel. And of course, that red colored paint that they put on it, you see even that being affected. The tiles will absorb moisture over time, and worst case, you can have a ceiling collapse into a pool. Again, suspended ceilings just are not the wisest choice in natatoriums. Return plenums under the ceilings or in the ceiling cavity, just not a wise choice. Airflow, extremely important in a natatorium. Your pool dehumidification system can be working perfectly, but if you don't have adequate airflow, you will get condensation on cold surfaces that are at or below the dew point. Here's another case of a suspended ceiling, cold air up above it, and you have condensation on the pool, on the ceiling itself, and you have a little rainforest going on here. Again, just open everything up, make sure they have good airflow through the natatorium, and condensation will be minimized. Here's something that we see quite frequently in hotels, large, small. You have a workout room or a little fitness room adjacent to the pool, and that's going to be kept at a lower temperature. Hotel pool is going to be at about 84 degrees. The air temperature will be at about 86. We recommend about 2 degrees warmer on the air temperature. Well, the exercise room or the fitness room is going to be kept at 70, 75, somewhere there, and you may have condensation on the windows. We also see, say, duct-free splits in these fitness rooms, which will put that glass surface below the dew point, and it gets sweating like this. It could also be that you don't have good thermal pane window or thermal breaks on the window frames themselves. So another fix to this would be, of course, high quality windows, thermal breaks, thermal pane, and wash that window with a flow of good dehumidified air on the pool natatorium side. Here's a case where they did have problems with insufficient airflow across the windows, sweating on the windows. It was running down the walls, and they actually put a gutter on here to drain into the pool drain or into some other drain. Yeah, that's a good way to remove that condensate, but not a good way. This is called efflorescence. What you have could be a combination of things, but you have humidity, chloramines, a compromised vapor barrier or no vapor barrier, and what that does is it drives the humidity, chloramines into the brick, into the mortar. It's going to drive lime through the wall, moisture through the wall, and in Chicago, when that moisture gets into the mortar and into the bricks, go through some freeze-thaw cycles over the years, and you'll start having the mortar breaking down, bricks actually breaking, and we have a major problem here. You need a vapor barrier, and you need to control humidity and chloramines. This is a very specialized application. I can't stress enough that you don't want to use a standard air handler for dehumidification of pools. They're just not up to the task. Pool dehumidification units have special coatings on the coil. They have different sequences of operation. They have deeper coils, 6, 8 rows sometimes. And they're just not up to the task. There is specialized equipment for this application. That's what you should use. Okay, let's get to some of the principles, materials, and designs of air distribution systems. Okay. You may run into some cases where you have an existing pool and you're going to run into problems like this. The air distribution is over the water. Okay, just not the right thing to do. Why would you blow air onto the top of the water to pick up moisture? What you need to do is, to fix this problem, is install a new supply duct and put the air where it's supposed to be, on the perimeter. Wash those walls, keep them free of condensation. Same thing with the windows. Simple task to do it correctly the first time, but if you need to fix a problem, you can install ductwork to wash the walls properly, wash the windows, and then return to the pool dehumidification unit. I've seen these in the Chicago area. Greenhouse type roofs. It's not really a greenhouse, of course, but treat it like a big skylight. And you have to maintain a good airflow across the entire ceiling in a case like this. There might be areas where air distribution is hard to get to, corners, hallways, that sort of thing. Just run a duct back there and make sure that you treat those areas, this little area of the roof that couldn't be reached by the by those main spiral ducts. Sometimes structural members have to be washed with a good flow of air as well. Doors, of course, must be treated. And here's another local example, McDonald's Lodge in Oak Brook. This was a build-on-site application with a pool pack unit. And we had to get, well, it wasn't us. This was done before our time with pool pack, but the equipment had to be brought through some mechanical doors 3 foot or 6 foot wide. Don't remember exactly which it was, but the unit was actually built on site by factory personnel. But pretty good air distribution system. They did treat the windows, the skylights. And again, you're going to have those cases where you can't get to a spot with air distribution. Baseboard heaters, that's a good solution too. They can be electric, hot water, whatever it takes to provide, flow of heat across that window for the winter months. Okay, so the main message here is you need to treat the perimeter of the building and also maintain a slight negative pressure in the natatorium. That's because adjacent rooms like that fitness room that we saw earlier, if you don't maintain let's say that you maintain a positive pressure, you'll drive moist, warm air into the fitness center, into offices, into adjoining rooms. You want to keep the natatorium air in the natatorium, and the way to do that is to maintain a slight negative pressure. Air distribution systems can be located below the surface, below the pool deck. Just make sure that you have sufficient diffusers to wash the windows and walls and duct up to skylights and other openings like that. Or it can be up high, and again, just make sure that your diffusers have sufficient throw to reach the pool deck. And again, you can duct up to the skylights and other window treatments like that. Oh, yeah.
A couple questions that came up. One of them was regarding I believe the question was regarding the negative pressure of the space. Approximately how negative should we keep it? How slight is slight?
Slight, the examples I've heard are, if you have 1,000 CFM of supply air, go about 10%. That I haven't heard actual a tenth of an inch or 2/10 of an inch, but typically it's going to be about 10% supply air, or your supply air minus about 10%, exhaust 1,000, bring in 900, or other appropriate amounts like that.
Yeah, in general, if you get things between like 0.03 and 0.08, or in this case negative 0.03 and negative 0.08, that's usually enough to ensure that all surfaces of your cube are negative relative to the rooms around them. So negative 0.05 would be your target for pressure if you were actually controlling the pressure. In John's case, like you said, most people aren't doing that. They're just balancing at one time for a certain amount of supply versus return. 10% being a good rule of thumb. The other question, I don't know that we have the answer to this, but I'll ask it anyway, was do we know how many watts a typical pool UV system runs?
No, that's something, we don't deal in that equipment. I was just introducing it. I would just Google pool UV systems, and you should be able to bring up submittals and that sort of thing that would provide that information to you.
Yeah, just as kind of a rule of thumb, UV lights that we use in HVAC, they're typically, for something that's the size of that, 50 or 100 watts. It's not going to be something ridiculously expensive to run. It's probably cheaper than buying the actual chlorine is my guess.
Yeah.
But like John said, we don't deal specifically with the pool treatment water side, so we don't have those check figures in our head for sure. All right, I'll turn it back over to John.
Okay,
Thanks.
Thank you, Ryan. Okay, again, high side, you can have the ductwork above. Just make sure that you choose your diffusers to blow down to the deck, treat, and wash the windows and walls appropriately to keep them free of condensation. Another scenario that we run into that we see a lot out here, high school swimming pools, college swimming pools, they're going to have a pool, and sometimes they'll have a separate spectator area. That's pretty unusual, but this is ideally what you want to do. You want to separate the two areas, let the pool dehumidifier handle the pool natatorium, and treat the spectator area as you would any other spectator area. This is another way to handle that situation where you don't have a barrier between the spectators and the pool. You could still have a separate outdoor air system that runs only during events. You will get some air from the pool area into the spectator area, and that's, it's just something you have to deal with, and this is a good way to manage the situation too. This is what we usually see, though. You have the pool dehumidifier handling the entire area, including the spectator area. Economics, comes into the situation, and you can only afford so much. But you can direct additional airflow to the spectators, so they have some evaporative effect that might help the situation. And again, these rooms are going to be, let's see, in a competitive swimming situation, you're going to be 78, 80 degrees water temperature, 2 degrees higher than that, so you're going to be 80 degrees or 82 degrees. Some people will find that a bit warm, but again, this is just another way to handle that scenario. So we have a question.
All right, question number 2. The air balancer should set the pool dehumidification system to maintain a slightly negative in the natatorium. True or false? I will launch the question right now. And while you guys are answering that, I'm going to read a comment from Andy, a gentleman who typed in. Said that they see some pool systems that are over-exhausted, and in some cases the opposite, where the locker rooms are actually the exhaust system for the pool area, which causes obviously all the lockers and shower heads and everything to start corroding away. So kind of going with the spectator discussion John had before about keeping it separate, the locker room should really have a separate system from the natatorium itself as well.
Okay, Andy, and thank you for bringing that up. We do, I have some slides that will be coming up showing exactly that. Not a good thing, but yeah, we'll talk about that a little bit more in coming slides.
I think everybody has answered the question. I'm going to go ahead and close the poll and show you guys the results of what you did. So you guys pretty much all got it correct. 99% of you said yes, it's true. They need to keep the pool dehumidification system as a negative as compared to the spaces around it.
Okay, and again, this is vitally important. You're not only trying to take care of that humidity and odors from the pool are not driven into adjoining areas. You don't want those substances driven into the materials as well. Concrete blocks, concrete, vapor barrier into the insulation. It's a snowballing of problems when that happens. Okay, what do we use for ductwork? Acceptable and highly recommended materials are galvanized steel with epoxy coating. Galvanized steel is just head and shoulders above what it was even 10 or 20 years ago. It's we see it on our cars. They don't rust anything like they used to back in the 60s and the 70s. Aluminum with an epoxy coating, that's a fine choice as well. Or plastic or fiberglass, may depend on what look you're trying to achieve. Architectural concerns, there can be other concerns as well, but these are probably the top 3 materials that we see in use for ductwork.
Would the plastic include the fabric type duct systems, or is that
no, that's separate.
separate
entirely.
discussion? Okay.
Okay.
Sorry.
Another one. I deal with Pool Pack a lot, and I've got some guys there that are okay with fabric ducts, some that aren't. So done properly, I think they'll be just fine. But here's some of the things to look out for. The material is going to be a filter when it first starts up. They are somewhat porous, so air will filter through them, so you'll get, the inside surface covered with dust that may be difficult to clean out. That may increase the external static pressure. I don't think that's really a huge factor, which might throw the fan into a bad region of the curve. I'm not sure that that's, actually been experienced. Dust bomb or reinflations. Typically when does a pool stop evaporating? Never. The system is going to be running 24/7, so this is not really any sort of major concern. Could rotate over time. Yeah, make sure it's installed properly and secured properly. It might be more difficult to do an air balance, but it depends on what diffusers are being used. This gets to that point. The diffuser should be sewn in so you can direct the flow where it's supposed to go. So that point about being difficult to balance, if you have a perforated duct like this, you're just going to get a wafting of air down to the surface that you're trying to treat, so not really appropriate for a pool. What you want is sewn-in diffusers to make sure that you can direct that air to the windows, to the deck, to the ceiling. These are available. I'm guessing they'll work just fine. And another question.
All right, let's launch this guy. Which materials are acceptable for use as duct materials? So we'll launch that. Choice A, epoxy-coated galvanized sheet metal. B, epoxy-coated aluminum. C, plastic or fiberglass. D, all of the above. Looks like 89% people voted, so we'll give it another 10 seconds or so. Three, two, one. I'm going to go ahead and close the voting and show you the results. So 97% of you said D, all of the above.
Okay, here we go again. All right, now some do's and don'ts of air distribution systems. Make sure you position your diffuser so you don't short-circuit the air. You just paid money to treat that air through mechanical cooling or heating. The other problem here is that this isn't going where it's supposed to go, washing the windows, the walls, the doors, and so on. Okay, Andy, here we go with your example about the locker rooms. I'm glad you brought that up because it would seem obvious not to do this, but it does happen, and that's why you knew about it. That's why we have these pictures here. You're seeing that these lockers are, badly rusted because this is used either as a supply or return, probably a return. Locker rooms are kept at cooler temperatures than pools. Again, pools are going to be kept at 82, 84 degrees, somewhere in that range for recreational, a little bit lower for competitive pools. But locker rooms aren't going to be kept anywhere near that temperature, so you have condensation forming on the lockers here, obviously, which cause them to rust as badly as they have here. And even stainless steel. Stainless steel is one of my favorite metals. I really like it, but even it can be affected by chloramines and by humidity. So obviously, big problems here. Poor air distribution design, poor humidity control, and looks like we have a problem with chloramines as well. Vapor barriers. You have to keep the humidity and the chloramines out of the walls, out of the insulation, out of the sheathing. humidity is going to seek a drier area. So you have the pool, which is a very humid area on one side of the wall, and the ambient air on the other side of the wall, much drier. The humidity will migrate through that wall if it's not stopped. It will get into the insulation. During the winter, that humidity is going to condense on the insulation. It'll make it soggy, and in the worst cases, it's going to freeze. And that dew point that you see on that upper right drawing will move closer and closer to the interior wall as that insulation gets soggy. Just a very bad situation there. You want to put that vapor barrier on the inside of the wall where it's warmer and stop it right there. So you want to stop that humid air, and this is where the negative pressure inside the natatorium becomes vitally important as well. You should have that vapor retarder, but nothing is perfect. And so you should have that on the warm side, maintain that negative pressure, and your natatorium will experience its full expected lifetime. Your swarms will be more comfortable. They'll be healthier. As I mentioned earlier, with those fitness centers and with exterior windows as well, all windows and doors should have a good thermal break in the frame. This is vital. Otherwise, you're going to have condensation on the interior surface of the windows, and that will drip down onto the sill, start getting into the wall, and anywhere it can find an opening, that's where the water will go. They should be maintained too. When you see that that window starting to clog up internally, that means the seal between the window has ruptured, has been compromised, and you start seeing condensation forming inside the window. So those have to be maintained, and your insulating value will suffer as well. You have to support that brick some way, but try to make sure that it's not a continuous lintel from the exterior wall to the interior wall. Use 2 pieces of angle iron instead of 1 piece of angle iron going from the inside to the outside. Okay, here's our 4th and final question.
All right, question number 4. What side of an exterior wall should the vapor barrier be installed on? A, warm side, B, cold side, or C, both sides? Just to give you more choices. Also, if anybody has any other general questions they want to type them in that question chat box after this poll closes, and we'll try to answer them towards the end of the presentation too. It's like 88, 89% of the people voted. We'll give it a little bit here. Take the last few folks. And we'll close it in 5, 4. I'm closing it now. And we'll populate the results for you guys. So most of you guys got it correct. 92% of you said that the exterior wall should have a vapor barrier installed on the A, warm side of the wall, which is correct.
Okay, and this is something that, again, you have to get this right. If you don't install on the warm side, if you were to install it on the cold side, moisture can migrate and will migrate to the exterior wall, condense at some point where it hits the dew point or below, and start condensing on insulation, and it's going to snowball from there in a bad way. Okay. Different ways of controlling dehumidification systems. What we do with pool pack equipment is we have what's called a cold surface temperature. We locate that on the coldest surface in the room. So it's going to be, say, a north window, north exposure window, because that's not going to get any sun, and that's going to be, on average, the coldest place in the room. If you can control to that point and keep that window free of condensation, everything else is a slam dunk. The system will work, and your natatorium will be properly maintained and managed.
Sean types in a question, and we should have probably been a little more clear. His question is, when we talk about 2 degrees higher air temp than the pool water temp, are we referring to the conditioned space temperature, or are we referring to the discharge air temperature out of the duct?
Okay, we're referring to the space temperature. So again, I'll give an example. Recreational pools, you want to maintain those, say, between 80 degrees and 84 degrees. Let's say that you choose the middle, 82 degrees. So the water temperature will be 82 degrees. The air temperature is 84 degrees.
The space air temperature.
Space air temperature.
Right, which means that the air coming out of the diffuser is it's not going to be 84, but it's going to be fairly close to that because we're trying to keep things reasonably neutral. So in the winter, you'll be adding heat, obviously. In the summer, you'll be dehumidifying more.
Yeah, you'll be dehumidifying year-round. You'll be dehumidifying. And actually, interesting point that was made to me recently was these are air conditioning systems, and we do have the means of rejecting air outside the building. If you attended an earlier webinar where I explained the operation of pool pack units, you have your evaporator coil, and immediately downstream you have your condenser reheat coil. So what we do is we cool and dehumidify the air, and at that point it's too cold to go back into the natatorium. So we reheat it immediately with hot discharge gas from the compressor. We recover that heat. So it's a very efficient way to maintain humidity. When we're above the set point for the room temperature, then we may have to reject heat outside. Are you really air conditioning? I guess in some senses, yes, but you're really just getting rid of excess heat because you're maintaining a temperature about, say, 85 degrees in the space. So again, specialized applications, special conditions, special sequence of operations, very specialized equipment. But I do appreciate that question.
There's several more in here. One of them is kind of related to that, so we'll ask that now, then we'll save the other ones. Farrad asks, what should be the air velocity, temp, and relative humidity serving the pool area?
It's going to be higher. I don't have the psychrometric table in front of me, or the performance data, I should say. It's going to be somewhat warmer. You saw my email at the beginning. If you could send me an email, I'll be glad to send you some information on that.
I'll put it in the chat box too, so you guys can just click on the link to John's email also.
And what I'll do for those of you that would like an answer to that question, I'll send a performance data sheet so you can see the actual numbers. Okay. Other questions?
There are, but we'll save them for the end because they're not on that exact topic.
All right. Oops, looks like we have a blank. Okay, well, I guess we'll do that. Okay, we're going to address the last of the questions here.
All right, so we'll see if we can get some of these. One of them, Joe writes in, Chicago building code ignores pool area and addresses air quantity per deck square foot. Any idea why that is?
Okay, that's correct. I think the ASHRAE code or the ASHRAE standards call for about 0.5 CFM per square foot of deck area. Chicago being, they just have special requirements. They require, I believe it's about 0.67 CFM per square foot of deck area. There's other ways of expressing it as a portion of the supply air. We visited with an owner not too long ago that brought up that point. I forget exactly what that was, but when I do a selection for a pool pack unit in Chicago, what I typically do is, I go out there and I measure the pool natatorium for volume because air changes are vital to treating the area properly. I get all that information, and for Chicago pools, I increase the amount of outdoor air to 0.67. For other areas around Chicago, 0.5 CFM per square foot is what we plug in.
Let's see if we have any other ones here. Anwar asks, what are all the variables required to size a dehumidification unit? Is there a rule of thumb?
I have a data input sheet that I use for pool dehumidification units. Weather bin data is the first thing that comes up. Square area of the pool in square feet, the temperature of the pool, and also the temperature of the air in the space. You can have very special applications, baby pools. You might see there are businesses in the Chicago area that have baby pools, and they maintain water temperature in the 90s, like 94, 92 degrees, because babies just will not go in the water unless it's that warm. And so you're going to have much higher space temperatures as a result too. Area of the natatorium, length, width, and height. I get as good a measurements as I possibly can. Heat loss for during the winter. I need to be able to plug in the heat loss. I can choose the correctly sized pool dehumidification unit just based on the pool area and the volume of the natatorium, but sometimes we need auxiliary heat. So in that case, I do need the heat loss of the building. Likewise, I need the heat gain of the building to properly size a unit. Those are the basics. I have a sheet that I fill out every time, and I get requests from time to time, hey, I need a 5,000 CFM pool unit. That is not the way to do it. I wouldn't size a fan based on just CFM. We need that information to properly select a unit. Another really important point here is that I do the bulk of the jobs that I look at are renovation jobs, replacement jobs. 3 out of 4 times the existing pool dehumidification unit is oversized. That's why I like getting on the job site so we can size it correctly, so it will operate correctly. It's going to be better for the swimmers, the natatorium, and for the pool owners, and for everybody concerned. So thanks for that question, Adam.
All right, Cliff asks if we can use demand control ventilation option for natatoriums.
Yes, you can. We do have, I believe there is a CO2 sensor option on the pool pack units, and that's a great way to go, not only for pool pack units, but for rooftop units. We sell a ton of demand control ventilation. That would be CO2 sensors and all the control sequence in the rooftop units. Why bring in outdoor air that you don't have to? It costs money to heat and cool that air.
The one thing I'll caution you about that requires you going all the way back to the first slide John had, and you have to have all those chloramines right, because if you start cutting back the ventilation air, and that's the only thing that's preventing people from getting all that chlorine, then you're going to be in bad shape. So you can't just randomly go add DCV to a system that doesn't have the pool water chemistry under control, like John mentioned way at the beginning, or you're going to end up in problems there.
There is a bit of a control mechanism there. When your eyes start burning when you walk into that pool natatorium, and I'm not.
Do we have an eye burning sensor we can install too?
Yeah, I mean, I've been in pool rooms. This was before I was in this business. I've been in pools where I go in the water, dunk my head in the water, and my eyes start burning. It was that bad. So, sort of like an idiot light on a car dashboard. But when it's that bad, just as when the oil light goes on your car, chances are you've already blown your engine. So things are really out of control if your eyes are burning and if you smell a really strong chlorine smell.
So based on that, the CO2 sensor obviously picks up none of that. It just picks up the people playing in the pool, right? So LSF has to be in check before you even think about doing that.
That's part of regular pool maintenance. You have to control your water chemistry.
All right, so Andy asked a question about the maintenance of the dehumidification units. Do more complicated dehumidification units with hot gas reheat require more complicated valves, and are they more prone to early failure? What would be the expected lifetime of a unit with good chloramine levels versus bad levels?
Treetop level, if you have bad pool chemistry maintenance, the equipment, the natatorium will not last as long. That being said, Pool Pack has 2 different coil coatings. One is the high core coating, which offers a 5-year warranty, and then the ElectroGuard Plus offers a 10-year warranty. Pretty bulletproof, but still you have to maintain your water chemistry. The cabinet also has a longer warranty as a result. So, we can protect the equipment, but that doesn't protect your swimmers. So again, just make sure your owners are aware of that. They should be, otherwise they shouldn't be, they shouldn't be a pool owner if they don't.
in regards to more complicated unit because of the hot gas reheat, it's basically one extra valve. I mean, and people are used to servicing hot gas reheat now. It doesn't mean, though, the guy that's servicing unit doesn't need to be trained specifically on that equipment, because he does. But it's not like it's crazy stuff that he has to spend a lifetime learning how to work on. It can be, if you know how to work on HVAC, you should be able to work on the actual equipment portion.
Oh, and I'm glad you brought up maintenance. We do have some contractors that are trained recently on pool pack units here in the Chicago area that we can direct you to. And we just had a couple of, we delivered some units last year, and those pool owners actually sent a couple of technicians last week to York, Pennsylvania for training. Training is offered several times a year at the factory, and it's great training. It's a business opportunity for contractors as well.
I like this next question a lot from Cliff. Is temperature setback during unoccupied hours an option to achieve energy savings?
Yes, there is. As a matter of fact, there's some options offering energy savings. It's called a flywheel type control. You can let the space temperature drop, and one of the options on these is a pool water condenser. So instead of rejecting heat to the air or to the interior air or to the outside, we can reject heat to the water, and the water acts as a flywheel, holding in the energy, and that's, rather than throwing that out, that provides energy savings right there. But yes, there is an occupied and unoccupied. It never turns completely off because, obviously the water never stops evaporating.
All right, Andy asks, speaking of oversized and DCV, is it possible to run fewer CFM at night, or perhaps turning one unit off? I think we kind of answered part of that. If you do DCV and everything else is okay with your pool chemistry, then obviously you can run lower CFM of ventilation air. Turning one unit off, I guess if you have multiple units, and they're serving one space, I guess, but that's not very common.
Yeah, except that then that area, if the air distribution of that part of the building is turned off too, then
if they're
condensation.
If they're twin ducted, I can see it. But if they're individually ducted and you're only going to dehumidify half of the windows and not the other half, that would be a problem.
So you're putting part of the building at risk. But I really like demand control ventilation for this equipment especially. I mean, I think it's really a great way to save energy, and it's a great way to treat the space and get only the ventilation air that you need.
Greg asks, is there a chloramine sensor available?
That I don't know. I'll have to get back to you on that. There's of course, when you test the water, that's what gives you your first indication that you have a problem. But I don't know if there's chloramine sensors. I have not heard of it, but I will ask. And just email me, and I'll be glad to answer that question, whoever emails me on that.
Yeah, Greg. I know you can get chlorine sensors. We've gotten for products before to put in the mechanical room of the pool area in case somebody leaves containers open or spills them and that kind of thing. But I don't know how well they would work for chloramine. It might be a different sensor that's needed.
Yeah, again,
different chemical.
Chlorine and chloramines are different. Chloramines are carrying organic matter, and bad for people, bad for equipment. But you go to the water, and that's your first indication, and you'll be doing that anyways, but I'll be glad to look into that for you.
I think we got our last question here. Joseph asks, do we have a rule of thumb on air changes?
Great question. Between 5 and 8 air changes per hour, that would be the air going through the pool dehumidification unit. The more you have going through the air, the more air changes you have, the higher the equipment operating cost will be. But if that's what it takes, it could be that you just have a difficult area to treat. Maybe it's a water park. Water parks are really interesting because you have not only the pool, when you have your swimmers in there, you disturb the surface of the water, more humidity comes off, but then you have these water slides, these water umbrellas and showers, fountains, and
water features.
Yeah, so that might require higher treatments. And sometimes we can maybe make the selection of the unit smaller if we increase the air changes per hour. It's sort of a moving target, and just so you fall within acceptable ranges on all the parameters, it's okay. And that's something that, it's best to be in front of the computer and make your selection. See how things change. The number of spectators in the room can have an effect on the size of the unit. The hours of operation will have an effect on the size of the unit. So great question.
All right, I'm going to read one more, and then I'm going to cut it off because we're going to be at the end here. The last one from Sean, and if you have more questions later, you can email them to us. Last one from Sean. In your experience, how much moving air is a problem? Can feel like you're standing in a wind tunnel when doing smaller pool rooms like residential indoor pools.
I'll agree with you. And, that's part of, sometimes I do see that on existing units, and maybe they're working, maybe they're not. But when I see excessive air changes, that means your air is going to be moving faster and may create a drafty kind of feeling. That's why, the adjustment of that parameter, the changes per hour, if you have your distribution system designed and your air changes, put it up in a level where you have excessive velocity, and that can create extra noise or that drafty feeling, maybe we can bump it down a little bit and still make everything else fall into the range that it should be in. So good question. That's one of those things you have to sit down and look at the program. And by the way, there's one other slide I want to show.
Sorry, is that the end?
Yeah, if we can. I have some sources here that I'd like to direct you to. Go to that one right there. There, sources. Okay, here's some of the sources I used. Poolpack.com has some great, 6, 4, 8-page documents. Pool Natatorium design, air distribution, water chemistry, efflorescence, chloramines. It's a great resource. Go there. The first button on the left is downloads. Go to the educational library. So again, that's Poolpack, POOPAK.com. And that's one place to go. CDAC, Smart Energy Design Assistance Center, right in our very own University of Illinois down in Champaign, Urbana. Some people went there. ASHRAE is a good source. For the pool chemistry, some of those pool chemistry slides I had, National Swimming Pool Foundation. But, good place to go. And for actual recommendations on materials, Poolpack has some direction there as well. So I would go there. I believe you can download the pool dehumidification selection software. If not, contact your TM or contact me, and we'll be glad to get you set up with that.
All right, I think we're all wrapped up. If you registered stating you were a PE that needed a PDH certificate, and assuming you answered all the questions and got the right attendance score and all that great stuff we mentioned earlier, then within the week you'll be emailed a certificate from Flo in our office. If you have any other questions that come up, give us a call or email us, whatever is easier. What that extra thing was. Oh, was it the first slide that had your email on it, John?
Oh, yeah.
All right.
All right.
I'll bring it back up. Go ahead, John.
And I know many of you probably know Ryan Hoger from other webinars and training classes, but some of you may not. He is our training director. He runs a ton of classes every year. So if you have any training needs, just go to our website, and all the classes available are there.
All right. Thanks, guys. We appreciate it.